about solving absolute value inequalities, right? Let's just review this process, and then we want to just make sure we have those patterns memorized. That's really important to have all the patterns memorized in order to solve absolute value equations or inequalities. If you don't have them memorized, you're kind of not going to have much success, right? So that's one thing we got to just make sure we take care of. We'll practice that a little bit today. So whether we're solving an absolute value equation or inequality, the three steps are always the same, right? Step one, we're going to isolate the absolute value. Step two, we're going to split it into two non-absolute value things, right? And then step three is we're going to solve those things just using regular algebra. And remember our patterns. If we have an isolated absolute value that's less than some number, and remember, what does that U stand for, by the way? But it's just kind of, it represents everything that's contained inside the absolute value. It might be complicated. It might be like 2x plus 3 or something. But whatever's inside then is either going to be, well, in this case, this is going to flip into an and inequality, isn't it? Right? So whatever's inside is going to be greater than the negative outside number and less than the positive outside number, right? If the isolated absolute value is greater than some number, then whatever's inside is either going to be greater than the positive number or whatever's inside is going to be less than the negative. Remind me how we remember which one goes with which. How do we know that in this first case it's going to split into an and compound inequality? Yeah, okay, good. So if we rotate the inequality 90 degrees which direction? Clockwise, then that's going to flip into an and symbol, isn't it? So we know it's and. If we rotate this one 90 degrees clockwise, we get a V, which is an or symbol, okay? And then let me ask you this. How many letters are there in the word and? 3. So how many parts are there to an and inequality? 3 separate parts. Okay. How many letters in the word or? 2. So how many separate inequalities do we get for an or inequality? 2. We get 2 different separate inequalities, right? With the and, we get 1 3-part inequality. Okay? All right. I would like you guys to practice this a little bit. So what I want you to do here is I want you to remind me how each of these 3 cases splits into 2. So go to the boards and real quick, why don't everybody grab one of these Kleenexes for your eraser and then just leave it on the tray back there when you're done. So remind me here, now this one we dealt with a while ago. If the absolute value of something, call it U, is equal to A, how does that split? Good. U equals either order, doesn't matter. U equals positive A, or we need the or symbol, or U equals negative A. Good. Okay, that's excellent. Okay, now what about this one? If the absolute value of something, isolated absolute value, is greater than a number and or. Or. Okay, so what's that going to look like? Is it going to look like 1 3-part inequality or 2 separate inequalities? 2 separate inequalities, because or has 2 letters. There you go. So what's one of them going to be? Either what's inside, U, is greater than the positive. Now think why? Because we've got to have oars on a boat. So if I've got some positive value of A that's going to be an endpoint, I want all the values to the right of that. Right? I want to have the right or on the boat is going to be the one that starts at some positive value and goes to the right from there. So I want values of U that are greater than, meaning to the right of, positive A. Or over on the left, I've got some negative value of A, some negative number, and I want the values to the left of that. So is that less than or greater than if I'm going to the left? Less than, right? Less than means left of. So I want all the values of what's inside, values of u that are going to be less than negative a, right? Makes sense? Either want really big really big positive values or really big negative values, right? So either u is greater than the positive number, what's inside the absolute values is greater than the positive, or what's inside is less than the negative. Now notice I write those again as two completely separate inequalities that I would just solve then, right? And then finally, what about this? If I have the isolated absolute value is less than some number, does that turn into an and or an or compound inequality? And. Good. And that has how many parts? Three. What goes on the left side? Negative a. And then u has got to be greater than that, right? So u goes in the middle. It's going to be greater than negative a and less than positive a. Okay, give me 1 to 5. You think you got it? Pretty sure you got it? All right. Prove it. Go do it again. Let's practice a little bit. Let's practice just a couple of these, and then I'm going to turn you loose. Okay, so what are we doing first here? Okay, I'm going to wait. I got everybody with me.
Isolate the absolute value.
Okay, and what do I do first to accomplish that?
You would do
Add 1, right? We're using inverse operations to isolate. So we add 1 to both sides. I totally agree with that. Okay, and that's just going to give us that, right? Now what? Divide by, negative 4. And what do I have to do, Gary? Got to flip. I divided by a negative, so I've got to flip both sides, don't I? Right? Because I'm dividing by that negative, I know I've got to flip that guy around, and then I'm going to get the isolated absolute value on the left, and negative 20 divided by negative 4 is positive 5 on the right. Good. Okay, so now what's my pattern? I've got an isolated absolute value of x plus 9 is greater than or equal to positive 5. Okay, so that's that pattern, right? Everybody agree? And or. Or. Okay, so how does that split then? Either what? Okay, good. Either u is greater than positive a, or u is less than negative a, right? And u just means what's inside the absolute values. Okay, good. So what's inside then is either going to be less than or equal to the negative or greater than or equal to the positive, right? There's my pattern. And I'm just going to, remember that's let's make this really obvious. I've got this or symbol in the middle. And I'm just going to solve each of those individually. There's only one step to solve those. What is it? Subtract 9. That's it, right? I'm just going to subtract 9 from both sides. And so I get my solutions are x is less than or equal to negative 14, or x is greater than or equal to negative 4. And if I were to graph those on a number line, negative 14 would be on the left, negative 4 would be on the right. Well, what's that look like? X is less than or equal to negative 14. Wouldn't that just look like closed endpoint at negative 14, graphing left? X is greater than or equal to negative 4 would be closed endpoint at negative 4, graphing right. Oars on a boat. What do you know? Okay. Thank you. Outstanding. Okay. All right. So how about last one? Okay, I'm going to give you a hint here. This one is one that is really quick. You don't have to do anything. Okay, and how come? because this is one of those examples where I've got an absolute value, an isolated absolute value on one side, and a negative number on the other side. We did something like this previously. Like, for example, we might have done something like this. Absolute value of 3x minus 5 equals -7. And what would the answer have been? No solution, because the output of an absolute value can never be negative, right? So that one was immediately no solution. Okay, but when you deal with inequalities, you can't just say, negative number, no solution. You got to think about it. Ask yourself a how often question. How often is the output of an absolute value equal to a negative number? Never. So the answer was no solution. But how often is the output of an absolute value greater than or equal to a negative number? Again, how often is the output of an absolute value greater than or equal to a negative number? Never? Always, isn't it? Because the output of an absolute value is going to be either positive or maybe 0, but never negative, right? 0 or a positive number, either case, those are outputs that are always greater than a negative number. True? Isn't 0 greater than a negative number? Isn't a positive number greater than a negative number? So this is always true, isn't it? Isn't the output of an absolute value always going to be greater than or equal to a negative number? Doesn't that make sense? Okay, so this one would be always. Always greater than or equal to. Well, it's never going to be equal to, but it's always greater than, right? Because it's always, this one would be all reals. Okay, what about, I'm just going to throw you a hypothetical. What about this one? Absolute value of x plus 7 is less than -10. How often is that true? How often is the output of an absolute value less than -10? Never, right? So that one would be no solution. Make sense? Everybody good? Okay, go to work. Assignment's up there.